Hey everyone, in this video we're looking at interpreting bivariate relationships, and we're going to be looking at that in terms of some values and then doing some more complex processes. So just be mindful that this is a complex skill. It's good that you are being exposed to it. However, understand that that this may be a more challenging topic. So if you're unsure, you're feeling like you didn't quite get it, speak to your teacher and go and discuss it further with them in regards to like what you're planning your outcomes are for essential mathematics, because that is one of those complex skills. All right, so your line of best fit is, we've done that already in other videos, so you can go back and have a look at that. You have your graph and you've got some data, and then you've applied a line of best fit over that data. Now that straight line has certain properties, and those two properties are the steepness, and the second property is the Y-intercept. Now the Y-intercept is where it just cuts, like where it intercepts or cuts the Y-axis. So those two properties there can be expressed mathematically. And that's what we would be looking at in this video, to have a look at those two things. So if we have a look here, you will normally get something like this where you need to construct a scatter plot, making sure that you've got your axes appropriately labeled, and then our data is being placed in the title, and then you try and draw a line of best fit to the best of your abilities. I've used Excel to do this because one, it's a lot quicker, and two, it's a lot more accurate. So, and that's what you would be doing. You'll be constructing these for your PSMT. So what we do is that we can take that information and interpret it in order to find the gradient and the Y-intercept. So that gradient can be found mathematically using this rise over run, and you need to find 2 points from the line of best fit. So what we're going to do is actually, I'm going to grab a different color. I might grab green, this one here. Let me see if it gives me, nope, a dotted line. No, that's okay. Okay, so what I'm going to do is I'm going to try and interpret, there we are. So try to use as close as I can to whole numbers. I can see like here with 1, actually I might go up towards, there we go. Again, it's a bit tricky with my rule, like obviously I'm limited by my mouse here. So if I draw up to there, and then if I take another one as well and draw across, and where those two lines intersect, so that's about, let's just say, we're estimating here. So let's call this point A. The coordinates for A are 4.75 and 3.5. And then the other one would be, so you could probably use that one there that's really close. I'll actually use a different color for that one. We've got 6, it's not the greatest line, but you get the ballpark, 6 and 4. I'm going to call that one B. B, 6 and, 4. And then what we need to do is work out the rise over run. So what we do is we take the difference between those numbers. So in this case here, so it's the change in the numbers, or we can count up between them. So I went like 4.75, 5.75, not quite 6, so 5.75. That would be like 1 point something. But how we can do that is we can go gradient. Oops, sorry, I'll change the color. So A would be over here. That's looking for the gradient equals the difference in rise and the difference in run. And that means we go back up here. So I'll bring that down here. it would mean the difference in our rise are these numbers. Yep, these numbers. So it's gone from 3.5 to 4. So we would write 4 minus 3.5, and then the run would be, it's gone from this one to this one. Got that right? But yeah, this one to this one. So 6 minus 4.75, and that would give us an answer of 0.4, and that's our gradient. Our Y-intercept. So you would take your line of best fit that you have here and extend it all the way. There we go, it's about as good as I can get. And like where it crosses the Y-intercept there, that would be your, sorry, Y-axis, that would be your intercept. So in this case here, the Y-intercept is going to be it's like 1.9, let's say 99, which is almost 2. So we'll just call it 2 for now, make it a little bit easier for us. And then what we can do is work out the equation. So the equation is this general format, and we just plug those numbers in for gradient. So whatever the gradient is, which is that one, goes here, and the Y-intercept goes in here. So if we do C, the equation, we have y equals mx plus c, and there's a multiplication there. Y does not change because it's the... And so then our m, which is our green or gradient, it goes there, so that would be 0.4. X stays there, plus 2. So make sure you understand where that comes from. There's the 0.4. This represents a 0.4 in the gradient formula. We use the letter M, and we use the letter C for the Y-intercept. And that's where this number has come from, over here. All right, so what you're going to do is you're going to pause the video. It's 7, 8, 9, the questions you'll be working through. You would then construct your scatter graph. So I would suggest that you do that in Blackboard in Excel. So what you can do is you can take a picture of it. I'm fortunate enough that it's obviously on my screen. And then I'm going to go to New, place that in there, and then like complete the values, mass and spring. And then when you do that, you have something that looks like a table of values. Obviously this is for a different thing. There's your table of values, and if you click on chart, add element, add a trend line and put that in, then it gives you a trend line on your data. So linear, and it'll come up with that dotted line on your graph. Okay, so then you can then do this where you find your points. Interesting. You find your coordinates, and then use that to find your gradient, and then find your intercept by inspecting. Okay, there we go, that's 7. There's 8, so you can pause, and there's 9, you can pause. All right, thanks everyone, bye.